moving on. So just now we have that for inverse function to exist, we need the function itself to be one-to-one. So of course, if the function is not one-to-one, then we say that the inverse doesn't exist. Okay, but is there any way that we can do or apply to this function f so that it has an inverse? So the idea is actually to restrict the domain. Okay, so restricting the domain actually means that instead of using the full graph, let's talk about the graph of the function. Instead of using the full graph, I would take only a portion of the graph, okay, such that that portion of the graph, it is one-to-one. The function is one-to-one. Okay, so this is what we mean by restricting the domain. Okay, so under this new domain, because it is one-to-one, then we say that the inverse can exist. Okay, so let's look at an example how we can restrict a domain to allow the inverse to exist. So for this question, we have the function f(x) equals to x cubed minus x. Okay, so let's focus on the first part. We are supposed to show that the inverse does not exist. Right? So to show that the inverse doesn't exist, I can actually make use of the horizontal line test, but in the opposite way. So I'm just going to show that for the line y equals to 0, okay, I have three different inputs that will return the same output. So you can see that if I sub x equals to minus 1, 0, and 1, the output will be 0. Right? It's the same for these three different input. So this means that my function is not one-to-one. Okay, and therefore inverse doesn't exist. Okay, so this is the showing part. So for the next part, we are supposed to restrict the domain, okay, so that the inverse can exist. Okay, because just now we showed that it doesn't exist. So now we are supposed to restrict the domain to this form, x less than or equals to k, such that the inverse exists. Okay, so the idea is that for inverse to exist, we need the function to be one-to-one, right? So the purpose of restricting the domain now is to make sure that in this new domain, my function is one-to-one. Okay, so for a start, okay, I always suggest if you can, you give a sketch of the graph. Okay, it will give you a very good direction of how to cut the graph. Okay, so in this example, this graph over here, you can see that I can take either this part of the graph, okay, the red one, or blue one, or the green one. Okay, each of this part, it will be one-to-one, because you can see that let's focus on the red one for now. If I use only the red part of the graph, there is no turning point because it's just increasing, right? So it is one-to-one, therefore the inverse can exist. Okay, so according to the question, I'm supposed to restrict my domain to this form. Let me change my color. Okay, x less than or equals to k. So according to my graph over here, you can see that actually I don't have to take the full red part of the graph. I can take a portion. Let's say I only take this part. It is okay, right? Because it is still one-to-one. It has a smaller domain, but it is still one-to-one, which is fine. But according to the question, I'm supposed to find the maximum k. See? Okay, I'm supposed to find the maximum k. So what it means is that I need to make sure, I need to restrict my domain, but at the same time, make sure that this domain is as big as it can be, right? So according to my graph, you should see that I should just let k be this value. This is the maximum k can go, right? Any bigger, let's say if I let k be this value, then it will not be one-to-one, right? Because it will contain this turning point over here. Okay, so in other words, I managed to break down the question. My aim is just to find what is this k value over here, which is just the x coordinate of the turning point here. Right? So what we can do, turning point, okay, we learn in secondary school that you can just differentiate, equate to 0. Right? So I differentiated, solving the gradient function equals to 0. I have x equals to plus minus square root 1/3. So according to the graph, you can see positive square root 1/3 should be this one, negative should be this one. That's why I can straight away conclude that k should be negative square root 1/3. Okay, hopefully this gives you an idea how restricting a domain helps in letting the inverse of the function to exist. We just need to make sure that the function in the new domain is 1 to 1. Okay. Okay, so the next part is about finding the formula of the inverse function. Okay, so formula means that we want to know what's the rule. What is the rule of the function? What is it going to do with the input? Okay, how is it going to undo the original function? Okay, so we know that inverse function, okay, what he does is that he will take the output from the original function, and he will follow a certain rule and return the input, okay, that is being used to get this output. Okay, so I'll just give an example, okay, this will clear all the confusion. So let's say you have a simple function fx equals to 2x minus 1. Let's just say that you have an output of 3, right? And then you are interested to find what input is being used to get this output 3. Okay, so in a normal sense, okay, what it means is that we want to find what is the x value that produces the output 3. Okay, so this is equivalent to saying we sub fx equals to 3 and then we try to solve for x. Okay, so I start off with equation 1 like this, and then I try to make x the subject. Okay, so we can see that to make x the subject, in this case, I will need to take 3 plus 1 first and then divide by 2. Right, so that's like the steps I need to take. I need to plus 1 and then divide by 2. Okay, so I'll have x equals to 2. That is the input that's being used to get the output of 3. Okay, so we just repeat this a few times more. Hopefully you can see what I'm trying to get to. So let's say the output now is 5. Okay, I do the same thing again, equate this. Okay, I try to solve for x, and you realize that to find x, I will still need to follow the same step. I need to plus 1 and divide by 2, right? It's the same thing. So if I give you a more generic form, let's say the output now is called y. Okay, so my aim is to find x, right? So to find x, same thing, I need to plus 1 divided by 2. So in other words, the rule is that I need to plus 1 divided by 2, no matter what is no matter what is the output. Right? To undo it, I just need to plus 1 divided by 2. That's why I can say that this formula over here, the blue one, it is the rule of the inverse function. Right? The function will follow this rule to undo the effect of the original function f. Okay? So this is what I can say. My inverse function, okay, if I input y, he will follow this rule. He will take y plus 1 divided by 2. Okay, so this is the formula of the inverse function. Okay, so as a common convention though, we like to write the input of a function as x. So basically all I need to do is to change the alphabet y to x. Okay, this doesn't really matter because this is just the name of the variable. You can call it y, you can call it z, or whatever alphabet you like. Okay, so as a common convention, we just simply change it to x. Okay, so to summarize the steps for you, okay, I will say that the first step is that you let y equals to fx. Okay, fx is the formula, the formula that you are given from the question. So in this case, we have this y equals to 2x minus 1. Then you try to make x the subject. Okay, because by making x the subject, you are trying to solve for x. You're trying to see how you can find the input, which is x. Okay, that gives you this output. Okay, so make x the subject. Okay, in this case, we get this x equals to y plus 1 over 2. And then the last step is just to conclude what is the formula, okay, by changing the y to x. Can see? Okay, so these are the 3 steps, okay, to find the formula. Right? So this is just a question for you to consider. Suppose we have the inverse function of f to x is the following true. Okay, is it equal, the green part, okay, f inverse, is it equals to f inverse f? Okay, so for now it feels like a yes, right? We know that f and f inverse, they undo each other. So this function, the formula will just be x. Why? Simply because if you put in any input, he will output the same thing. Because f and f inverse, they will just cancel out each other, the effect. So if you input x, you'll get x. Same for the blue part over here. okay, because they undo each other. If you input x, you get x. So it feels like they are equal, okay, but the problem now is that they are not, because the domain is different or might be different, okay. So this is one thing you need to remember. If two functions share the same formula, we need to check whether the domain is the same. If the domain is different, we say that the two function is different, okay, they are different, right? So in this case, let's take a look at exactly what the domains of the green and the blue functions lah. So the domain of the green function, f inverse, we discussed earlier that it's just the domain of f inverse, right? So this domain of f inverse is just the range of f. Okay, this is what we discussed earlier. And the domain of the blue one, f inverse f, is just the domain of f. Okay, so in general, the domain of f and range of f, they are different, right? So in other words, I can say that the domain of f inverse f and the domain of f inverse, in general, they are different. That is the reason why, in general, these two functions, they are not the same, even though they share the same formula. Okay, so just a quick example lah. Suppose you have two functions f and g. They share the same formula. It's 3x plus 4. But then one has a domain x less than 2, one has a domain x less than 4. Okay, so because of this difference in domain, we say that these two functions, they are not the same. Okay, so just remember. So the next part is to understand what is the relation of a function and its inverse. So graphically, what we can say is that the graph of f inverse and the graph of f, they are related in this way. Okay, they are just a mirror reflection of each other in the line y equals to x. Okay, so I have an example for you here. The blue graph is just a simple quadratic function, fx equals to x squared. Okay, and the red function is the inverse function, square root x. Okay, the green one, of course, is just the line y equals to x, the diagonal line. So you can see that the blue and the red one is just a mirror reflection in the line this. Okay, imagine that this is your mirror, you reflect the blue one, you will get the red one. So this is the graphical relationship between a function and its inverse. Okay, so the observation we can see from this example is that the intersection of the function, the blue and the red one, okay, of course this is just a specific example, but in general it's always true. The intersection of the blue, the function and its inverse will always lie on the line y equals to x. So you can see in this example, the intersection is here and here. Okay, the intersection of the function and its inverse is always on the line y equals to y equals to x. So how we can apply this idea is that, let's say the question wants you to solve fx equals to f inverse. Okay, so of course you can do the brute force way. Okay, that means you just write down what's the formula for f, write down what's the formula for f inverse, and you try to solve for x. But then, a lot of the times if you do that, it is actually not easy. It will make the problem very complicated. So the idea is actually to make use of this observation over here. Because I know the intersection of the two graphs, okay, the original and the inverse function, it will always lie on the line y equals to x. So why not we consider the intersection of the original function and the diagonal line, right? If you can see that let's say if I look at the blue and the green dotted line, the intersection of these two graphs will also be these 2 points. It will still be the same 2 points, right? So why not let's just solve this simpler equation. Okay, so this is the application, how we can use this observation over here. Alright, so that comes to the end of this lecture. So make sure that now you can describe what are inverse function, what's the condition for inverse function that exists, okay, and what it means to restrict the domain. Okay, why do we want to restrict the domain? Okay, how do we find the formula of the inverse function, right? And the relationship between a function and its inverse. Right, see you in the next lecture.